Okay. The first question, if you read it, you're trying to find a relationship between two things, exam and hours. So usually when you try and find the relationship between two different things, it's regression. So we know that we're trying to do the question regression. Now, the first thing you need to know is whatever you try to predict, that's your y. And they tell you in the question that you're predicting the exam score. That means that exam is your y variable. So all the different sums given, we need to write them in terms of x and y. So they give you the sum of x, 188. They give you the sum of y, 793. They give you the sum of x squared. That would be 3832. So x again is your hours, y would be your exam. So the sum of exam squared also given, and the sum of the multiplication of the two also given, 15540. Now the first part in the question is to find the relationship, the equation. It's called the y hat equation. It's called the regression equation. It's called the least square equation. And it's basically the famous mx plus b. But in regression language, we don't say mx plus b, we say b0 plus b1x, where b1 is your slope and b0 is your y-intercept. Okay. To be able to calculate this, there are some formulas involved. The first formula is your SSX. It's the sum of x squared minus the sum squared over n. The sum of x squared, that's the 3832. The sum of x, that's the 188. And there are 10 numbers. You do the math for this, and it's 297.6. I'm going to add it here. 297.6. You're also going to need to find the SSY, which is the sum of y squared over n. It's the same formula, but in terms of y. Sum of y squared is the 65143. Sum of y is 793. And there are 10 numbers. You do the math for this one, and that gives you 22581. 22581. So you have the two SS's. You also need to find the SSXY. That's the sum of xy, sum of x, 793, and there are 10 numbers. You do this, and your SSXY would be 631.6. Now, this is how you find all the SS's. There's also one more SS that's usually good to find. It's the SSE. E stands for error or residual. Once you find the three SS's, the SSX, the SSY, and the XY, it's usually good practice to also find the SSE because you'll need it later on, and it's based on the three of them. The equation for this is SSXY squared over SSX. So your SSY, that's a 2258.1. SSXY, that's a 297.6 squared. And SSXY, that's the 631.6, and the SSX is the 297.6. So now I have my four SS's. I forgot to do this in the calculator. If you just wait until I get the calculator, I'll be back. Yeah, so you go and you put the numbers. So you have 2258.1, 631.6 squared over 297.6, and that gives you your SSY 9176485. Okay. So you still, all of the, to be able to do the equation, B0 and B1, intercept and slope, we always start with finding the slope first. Your slope is going to be SSXY over SSX. So the 631.6 over 297.6. And you do this, and that gives you the slope value of 2.1223. This is your slope. And once you do the slope, you can find your B0. That's basically average of y minus the slope average of x. So it's a good thing to put the two averages here, average y and average x. Average y would be the sum of y over n. So it would be this number over 10, so your average is 18.8. Average y would be the sum of y over n, would be this number over 10, 79.3. So you put everything here, so your B0 is average y 79.3, slope 21223, and average x is 18.8. You do that, and that will give you 39.4008. That's your intercept. Once you have the slope and the intercept, you can put everything in the equation. Y hat equals B0 B1x. I know that this is exam score. B0, we found this to be the 39.4008. We found the slope to be 21223, and x would be hours. This is the equation that we're looking for. Good? Question B is to do this using hypothesis testing. Can you prove statistically now that there is in fact a relationship between hours and exam, and how strong this relationship is? So we're testing if there is a relationship of the two related. So what we do is we put H0, HA. In terms of symbols, we say rho equals 0, not equal 0. This means no relation between hours and exam percentage, and this means there is. In general, in any hypothesis testing, if you're able to prove that p-value is less than or equal alpha, reject H0. Now alpha is the level of significance. It's usually given in the question when they're asked for the hypothesis, do it at alpha 5% or 1%, or do it at the level of significance of 1%, 5%. If they don't mention, use 5%. So if there is no mention of alpha, use 5%. And in your question, there is no mention of alpha, so we're going to say 5%. So your p-value, less than or equal 5%, we're going to reject H0. Okay. Then the section after this called test and analysis. So the test we're going to use for this, since we're testing relationship, is this formula. R square root 1 minus r squared n minus 2. But there are some calculations involved. So I'm going to erase some of this. Remember the equation. The first thing you need to calculate is R. And the formula for R is you take your SSXY square root of SSX times SSY. You have SSX, you have all of this, so you take your calculator, fraction, top is 631.6, the bottom is a square root of 297.6 times 2258.1. This will give you 7705. This is called coefficient of correlation. The coefficient of correlation or COR. You also need to do R squared, where you take this number and you square it. Gives you 5936. This R squared is coefficient of determination. So once you have r and r squared, you can put everything in the formula, in the t formula here. Remember, it was r, so 7705, it was 1 minus r squared, 5936, and n minus 2. And when you put everything together, this gives you 3.4185. Okay, I'm gonna stop. This will be part 1. I'm gonna stop here. When we come down, I'll talk about this again from the start quickly. Okay.